About electric potential energy and electric potential. So in this video, I'm going to talk about the work done and electric potential energy. Electric potential energy is simply the energy required to move a charge against an electric field, and it is given by the formula: the change in electric potential energy is equals to negative work performed. So for example, if we have two plates, a charged plate, positive charged plate, and a negative charged plate, then the work done on a charge Q in moving it from point A to point B is equals to force multiplied by distance. And this force is the electric force. Electric force is calculated by multiplying the charge Q by electric field. So the work done will be QE, which is the force, multiplied by the change in the distance. So the change in distance, which is the change in x. So this is the formula for work. Therefore, the potential energy, we said, is equals to the negative work, and work is equals to the force multiplied by the change in x, which is the force is simply the charge multiplied by the electric field, that is the electric force, where Q is charge in coulomb and E is the electric field in newtons per coulomb, and x is the distance moved by the charge. So potential energy is negative work, which is equals to negative QEX. So let's have an example. We see how we can calculate potential energy. For example, a proton is released from rest at x equals to -2 centimeter in a constant electric field with magnitude 1.5 by 10 to the power 3 newtons per coulomb, pointing in the positive x direction. Calculate the change in electric potential energy associated with the proton when it reaches x equals to 5 centimeter. So to solve this question, we need to draw a diagram to see what is happening, or to illustrate what is happening in this question. So they are saying we have a proton which is at rest, x equals to -2. So we're going to show that on a diagram. So we have a proton initially at rest at x equals to -2 centimeter, which is now fired in an electric field, and it reaches x equals to 5.00 centimeter. So we're going to indicate that here at 5.0 centimeter. So the distance from the initial position -2 to the final position, which is 5 centimeter, is simply the final distance, which is 5, minus the initial distance, which is 2. So that will result in 7 centimeter. So the proton, when it reaches 5 centimeter, it has covered a distance of 7 centimeter. So what is the change in electric potential energy? So electric potential energy, as we already said, it is given by the negative work, which is equals to negative QE multiplied by the change in x, where Q is the charge, and the charge for a proton is 1.6 times 10 to the power -19 coulombs, and E is the electric field, which is already here in the question, which is 1.5 by 10 to the power 3 newtons per coulomb, and the distance is x. Remember, distance needs to convert it in meters, so we're going to divide that 7 centimeter by 100, and it will be 0.07 meters. So our potential energy will be equals to -1.68 by 10 to the power -17 joules. So that is the potential energy. And B is saying an electron is now fired in the same direction from the same position. What is the change in electric potential energy associated with the electron if it reaches x equals to 12 centimeter? So in the same way we have solved A, try to solve this one. In this case, use the charge for electron and at a distance of x equals to 12 centimeter instead of 5 centimeter, and let me see your answer in the comment section. So thank you very much for watching. Remember, don't forget to like, subscribe, and leave your comment in the comment section below.